Today we'll see the fifth module. Okay, fifth module has topics like network analysis, game theory. All those are some of the topics that comes in the fifth module. Okay, so the first part you have network analysis, and second part you have game theory. Okay, so today we'll see the first part. Okay, in network analysis, you might already know CPM and PERT are some of the network methods that are used for project management. Okay, or network analysis, we use two methods like CPM and PERT. You must have heard of such names. Okay, so before we go on to CPM and PERT, we'll just see some theory and then we'll go to CPM and PERT. Okay, so before we start, what is a project? Okay, a project involves large number of interrelated activities. Okay, for example, the construction of a dam. Okay, first of all, you need to go and visit the site. You have to do the site inspection. Okay, and then there are different tasks that you need to complete. Okay, only then construction of a dam will be complete. Okay, so that is a project. So similarly, you will have different types of projects. Okay, for each project, you will have interrelated activities, or it is also called as tasks. Okay, that must be completed on or before a specified time limit. Okay, in a specified sequence. Okay, there is a specific sequence. Okay, you cannot do the last activity first and then go for the first activity. Okay, you have to first of all inspect the land for construction of a dam. Okay, only then. So there is a proper sequence that should be followed. Only in that sequence we have to complete this project. Otherwise, the project will not be a success. Okay, with specified quality and minimum cost of using resources. So what are the different types of resources that we can use? That is personnel, money. Okay, so that is people, money, materials, facilities, and space. Okay, so using all these resources properly, we have to go for the project. Okay, so project follows some specific sequence of activities that has to be followed in that same order. Okay, so for completing a project, we have something called as a network analysis. So this entire project, we will draw it in the form of a network. Okay, first activity connected to the second activity, like that we'll draw a network. Okay, that analysis of that network is called as network analysis. Okay, so network analysis, network planning, or network planning and scheduling techniques are used for planning, scheduling, and controlling large and complex projects. Okay, so using all these techniques, we can actually compute how a project can be done. Okay, which is the critical activity. Critical activity means the activity that takes the most of the time. Okay, maximum time which activity consumes. Such an activity is called as a critical activity. Okay, so when we draw this project in terms of a project network, okay, or network, when we analyze it in the form of a network, we'll be able to see which activities are taking most of the time, which is the critical activity, and how we can crash this critical activity. Crashing critical activity means if the critical activity takes 20 weeks, okay, crashing the critical activity means we are trying to complete it within 18 weeks. Okay, something like that. Okay, so theory part, we'll go further. Then we have network. Network we already saw. Network is a graphical representation of arrows and nodes for showing the logical sequence of various activities to be performed to achieve project objectives. So what is that? A project, we are actually depicting that in the form of a network. Okay, it shows the logical sequence, one after the other, what are the different activities that follow. Okay, that pictographic representation or graphical representation of a project is called as a network. Okay, now for network, for analyzing a network and for planning the scheduling activities and all, we have two techniques, that is PERT and CPM. Okay, PERT stands for Program Evaluation and Review Technique, which is also called as PERT. Okay, then we have something called as the Critical Path Method. Okay, that is CPM. Okay, for example, you have to study what are the differences between CPM and PERT. What is CPM, what is PERT, and then what are the similarities between CPM and PERT. Okay, CPM is actually used for projects that we already know the time. Okay, for each activity we know how much time it is going to take. If we know that beforehand, okay, for such project we'll be using critical path method. Okay, for estimating the critical path. Okay, is it clear? So CPM, in each activity there is a project. Okay, the project is actually we know how much time each activity takes. Okay, in such cases, we will be going for CPM, okay, for analyzing that network. Okay, if the project is very new, okay, if the project is a new project, okay, we don't know for each activity how much time it takes. Okay, in such cases, we'll be going for PERT, that is PERT. Okay, so in PERT, we have three different times that will be given for each activity. Okay, one is optimistic, one is pessimistic time, and most likely time. Okay, don't worry, you will see that. Okay, when you solve the problem for PERT, at that time we'll be seeing all those details. Okay, so that is a main difference between CPM and PERT. Okay, what's the difference? CPM is for projects for which we already know the time of each activity. Okay, that is almost for repetitive projects we use CPM. Okay, but PERT is used for projects that are very new. Okay, for each activity we don't know how much time it will take. Okay, in such cases, for questions they will give us three times. Okay, one is pessimistic time, one is optimistic time, and the last one is most likely time. Okay, you don't have to write it all these things, everything is written in the theory part. Okay, then we have the similarities, then you have the dissimilar differences of CPM and PERT. All that I'm not discussing now, you can just read it. Okay, then we have the significance of using PERT and CPM. Of that also you can read it. Okay, next important thing is phases of project management. Okay, phases, we have three phases. First one is the planning phase. Okay, planning phase, you have different types of steps. So the main thing that happens in planning phases, you will actually list out what are the different activities. Okay, what is the different time that is taken for each activity. Okay, what are the different resources that is required for completing each of this activity. Okay, so the main thing that happens in planning phase is developing a breakdown structure. Okay, you break the entire project into small activities, and then you actually assign. Okay, there is a work package. Work package means the smallest work that can be done. Okay, for each work package you will assign people. Okay, people and resources to that work package. Okay, so the entire project is there, you will break it down into small work packages. Okay, and then you will assign people, resources, money, facilities, space, everything to this work package. Okay, so that breaking down phase is called as planning phase. Okay, second phase of project management is we have the scheduling phase. Okay, scheduling phase, what happens, we are actually forming this network. Okay, so in the first phase, we got what are the different activities, what are the different time that is required. So the second phase is we are actually going to form this network diagram. Okay, using this, the details that we got from the first phase, using those details, we are going to draw the network diagram in this scheduling phase. Okay, so just read this. Once all activities have been identified and given code. Code means just name. Okay, project scheduling is done. Project scheduling is done once the first phase gets completed. Okay, for this we will draw the precedence relationship. Precedence relationship means after one activity, the next activity follows. Okay, so precedence means what? If this is an activity, okay, sorry, this is an event. Okay, we have an activity. Activity is represented by this arrow mark. Okay, so if you have an activity A over here, or if you have an activity B over here, which is the precedence activity for this, it will be another activity that is called as A. Okay, so if there is an activity called as B, what is the precedence relationship? Okay, precedence means an activity that comes before B. Okay, that is A. So like this, we'll be drawing the network diagram. Is it clear? And the circles are called as events. Okay, events we'll be writing as 1, 2, 3, etc. Okay, so A, B, C represents our activities. Okay, for example, site inspection, that will be A. Okay, B will be getting the proper materials. Okay, that will be B. Okay, so before B, what should follow? A should follow. Okay, before B, A should be completed. Okay, so A is called as the precedent activity of B. Okay, precedence activity of B is A. Okay, now the circles are called as events that are marked by 1, 2, 3. Okay, so activity you can either You can either write activity as A, B, or you can write activity as 1, 2. The activity that comes in between 1 and 2 is A, right? So you can write it as 1, 2. Okay, you can either write it as A or you can either write it as 1, 2. Okay, now activity B, how will you write it as? B, you can write it as 2, 3. Okay, B, you can write it as activity B, you can write it as 2, 3. Okay, so once again, scheduling phase is the second phase of our project management. Okay, in that what happens, we are actually drawing the network diagram using the precedence relationship. Okay, precedence relationship means if you have an activity B, then what is the precedence activity that comes before B? Okay, that is A. So such details will be given in the second phase, that is scheduling phase. Okay. Now, the last one is in the phase, that is project control phase. Project control phase means we have decided everything in the second phase. Okay. Actually, we are going to check whether the actual project follows the network diagram. Okay, that is what we check in the project control phase. Okay, so what happens refers to the evaluation of the actual progress against the plan. Okay, so all the planning has been done in the second phase. So third phase means we are going to check whether the plan and the actual reality of the project goes almost the same. Okay, if there are significant differences for the plan and for the actual progress of the project, then what we do is we will go for reallocation of the resources. Okay, for the next part of the project, we will again reallocate the resources. Okay, clear? So that is the three phases of project management. We have a diagram here. So if any theory part comes from this chapter, okay, related to project management, you can draw this figure also. Okay. Project planning is the first phase. There we are actually breaking down the structure into different parts. Okay, we are actually dividing the project into activities, events. Then for each, we are dividing it into work packages. Okay, the smallest work that we can do is work package. Okay, and then we'll assign for that resources, time, people, facilities, space, everything to that. Okay. Second phase is project scheduling. There we'll draw the network of activities. The network diagram is drawn there. Then we form the Gantt chart. Okay, Gantt chart is again for resource allocation. Okay, then we go for scheduling of resources with respect to cost and time. Okay, then we go for the implementation of the plan. Okay, implementation of the plan actually goes into the third phase. Okay, then periodic cost reports are generated. Actual task performance data is generated in the project control. Okay, so if there is any deviation, what do? Again, we will go for the project scheduling phase. Okay, which is the second phase. Okay, so if there is any deviation in the project control phase, we again go to the project scheduling phase and then we will reallocate the resources. Okay, again, this is actually a loop. Okay, so that is the relationship between phases in the project management. Okay. Next, we have some important terms that you need to know for solving the problem using PERT and CPM. Okay, first one is event. I've already told what is an event. Just read. Event is they represent project milestones. Okay, that is start or completion of an activity or task and occur at a particular instant of time. Okay, so events are actually represented by circles. Okay, so here we have. Okay, suppose there is an activity A. The start of this activity is represented by the first circle. The end of the completion of this activity is represented by the second circle. Okay, first circle I'm naming it as 1. Second circle I'm naming it as 2. Okay, this is called as the starting event. Okay, start event, and this is called as the end event. Okay, this is the end event. Okay. Now, the start event is also called as the tail event. The end event is also called as the head event. Okay, because this is progressing to the event 2. No, so this is the head of the activity. Okay, this is the tail of the activity. So 1 is represented by the tail of the activity and 2 represents the head of the activity. Okay, and how will you name this? Naming of events is also very important. Okay, always the tail will have a smaller number than the head of the event. Okay, or head of the activity. Okay, this is the activity that is represented by A. For example, site inspection for dam construction. Okay, all these are the activities. Okay, the start of this activity is represented by the tail of the activity, and the end of this, once the activity is completed, we represent that also with a circle. Okay, that circle is called as the head of this activity. Okay, and how will you name this? The tail will have a smaller number 1. Okay, and the head will have a bigger number, that is 2. Okay, and this is the activity. It is represented by an arrow mark. Okay, the size of this arrow mark has no meaning. Okay, if it is a bigger arrow mark, it takes more time. There's nothing like that. Okay, this is just to represent that an activity has to be completed. Okay, that activity is represented by A here. Okay, that is all the meaning of this. Okay, so we were thinking about event. Okay, event means these circles are called as events. Okay, and there will be 2 events that has to be written for one activity. First event is starting. Second event is the ending of the activity. Clear? Now they are represented by circles. So the circles are also called as nodes. Okay, and then we have 2 types of events. First one is merge event. Okay, if 2 or more activities are coming together to form the end event. For example, here we have an activity A. Here we have an activity B. Okay, 2 things together. When both of it are completed, we will mark the completion. Okay, such terms are called as merging. Okay, so merge event, and then we have burst event. Burst event means we have an event here. From this event, 2 activities. See, burst event means here we have an event. Okay, here we have an event and 2 activities are going out of this event. So it is called as a burst event. Okay, an event that represents the initiation of more than one activity. These 2 are activities. This event represents the initial, okay, starting of 2 or more activities. Okay, such events are called as burst events. Okay, then we have what is an activity. We already told what is an activity. Represents project operations to be conducted. So what are the different things? What are different steps that we need to take to complete a project? Okay, that is called as an activity. Okay, for each activity we need resources, okay, and time to complete. Okay, except for dummy activities. Okay, dummy activities is something that we'll see in the rest of the portions. Okay, now how will you represent an activity? It is represented by an arrow mark. Okay, before the arrow mark you will have a starting event. It is called as a tail. After the activity is completed, it will go to a completion event that is also represented by a circle. Okay, and it is called as a head. Okay, you have some formulas for doing CPM and PERT. In that we have this I and J representation. Okay, I means it represents the starting event. Okay, J represents the ending event. Okay, so the arrow mark will go from the starting event to the ending event. Is it clear? Now, activities can be classified as predecessor activity. Okay, predecessor activity. Predecessor means what? Suppose you have over here. Predecessor activity means over here. Suppose you have an activity B. Okay, predecessor means one who comes before. Okay, you say prepone and all, right? Prepone means before. Okay, postpone means after. So predecessor means one who comes before. Okay, so before A, which activity, before B, which activity needs to be completed? Okay, A needs to be completed. So A is the precedence activity of B. Okay, so that is called as a predecessor activity. Okay, next one, successor activity. For problems, we'll be using this predecessor term. Okay, so predecessor means B has to be completed only after A. So that is the meaning of predecessor activity. Okay, now what is successor activity? Same thing. After A, which activity follows? So, okay, so B is the successor activity of A. Okay, that is the meaning. For problems, you have to see predecessor activities. Okay, everywhere predecessor activity will be given in problems. Okay, then we have a dummy activity. This is very important. What is a dummy activity? For theory portion, they might ask you what is a dummy activity. Okay, so I'll tell you what is a dummy activity. Suppose this is an event. This is a starting event and this is an ending event. Okay, we have 2 activities like this. Okay, A and B. Okay, and then we have some other activity that come after the completion of A and B. We have some other activity called as C. Okay, these are the nodes 1, 2, 3. These are the events. Okay, According to network analysis, okay, two activities should not have the same head and the same, same tail and the same head. Okay, this is the tail, this is the head. Okay, so according to network analysis, this is not allowed. Okay, clear? So dummy activity is very important when you draw the network diagrams. Okay, so what is that you have to consider over here? Suppose there are two activities in between the same tail and the same head. Okay, so for activity A and B, one is the tail, one is the event that is represented as the tail, and two is the event that is represented as the head. Okay, but according to network analysis, we should not have the same parallel activities should not be happening. Okay, that means the two activities should not have the same tail and the same head. Okay, that is not allowed in network analysis. So what we'll do? We have to introduce something called as dummy activity. Okay, how will you do that? Suppose you have one, here you have one, here you have two, okay, and over here you have A. Okay, so B, what you will do? B, I will draw to another node. Okay, 3. Okay, I will draw B here, and then what will I do? I will connect this with the dotted lines to 2. Okay, so in effect, C over here, C needs to be started only once A and B are completed. That's the meaning of this, no? But this diagram is not allowed in network analysis. So what we do is we draw another alternative. Okay, that is we are introducing dummy 1. Okay, it is represented as D1, D2, etc. Okay, and from here I will go for C. Okay, so what is the meaning? C has to be completed only once A and B is completed. Okay, C has to be started only once A and B is completed. Same meaning we'll get it from this diagram also. Okay, so instead of using this diagram in network analysis, we have to go for this diagram. Is it clear? Okay, so A and B you should not draw parallelly. Okay, we have to always go for such a diagram like this. Okay, so here you have A coming in this straight. Okay, here you have B. The same B flows through D1 also. Okay, through this branch also the same B itself flows. Okay, so in effect what happens? C is actually started only after A and B is completed. Okay, clear? So instead of using this format, we have to always go for this one. Okay, so parallel activities are not allowed. Okay, but otherwise this is allowed. We have over here. Okay. Okay, is this allowed? Here we have A, here we have B, here we have C. Is this allowed? Is this allowed? This is allowed because two activities are not having the same head and the same tail. That is not there in this one. Okay, only if two activities are having the same head and the same tail, okay, same head and the same tail, only then we need to redraw that diagram using the dummy variable. Okay, over here these are not parallel activities. Okay, they are not having the same head and the same tail. Activity A is having tail as 1 and head as 2. Activity B is having tail as 2 and head as 3. Okay, activity C is having tail as 1 and head as 3. So all are having their own unique head and tail combinations. Okay, so this is allowed, there is no problem, but this one is not allowed. Okay, so such diagrams like this we have to redraw it into this format. Clear? So this is very important, dummy. Okay, variables using dummy. Okay, next one. Yeah, next we'll see some of the rules in network diagram. Okay, for solving a project, okay, we have to convert that project into the form of network diagrams. Okay, so we have to see some of the rules that are used for network diagram. Okay, we'll see each rule. Arrows represent activities and circles represent events. That you already know, right? These are the two events that is connected by an arrow. Arrow is called as the activity. It is represented as A, or it can also be represented as 1, 2. Okay, so 1, 2. So activity can either be represented by alphabets or they can be represented as the numbers that comes in between. Okay, that is 1 and 2. Okay, so this activity can be represented like this. 1 actually shows the event. Events are represented by circles. Okay, every activity should have a starting event that is called as a tail, and every activity should have an ending event, completion event, that is called as the head. Okay, the arrow should go from the tail to the head. Okay, numbering, how will you do? The tail should have a lesser number than the head. Okay, the head should always have a higher number, that is 2. Okay, now each activity should be represented only by one arrow and must start and end in a circle called event. Okay, the tail of the activity represents the start and head the completion of the work. Okay, so if you are having two events like this, you cannot have A and A here. That is not allowed. Okay, all the activities should be unique. If that is A over here, then it should be B below. Okay, and parallel activities are not allowed, so you need to introduce dummy. Okay, dummy should be introduced. Next one, third point here. The event numbered 1 represents the start of the project and is called as the initial event. Okay, all activities emerging from 1 should not be preceded by any other activity. Okay, so suppose you are having one network diagram like this. Okay, network diagram like this. This naming I am doing over here. Network diagram should be always represented with arrows. Okay, there should be a direction. Okay, I'm representing these events 1, 2, 3, 4, 5, 6, 7. Okay, the event that takes 1 is called as the starting event. Okay, there should not be any events before the starting event. So the event that takes 1 as the node number will be the starting event. There should not be any events before this. Okay, there should not be anything before this. The last event is represented by 7. After the last event also there should not be any other events. Okay. Now an event carrying the highest number denotes the completion event. Okay, here which is the highest number? Highest number is 7. So the highest number event will be taken as the completion event. Okay. A network should have only one initial event and only one completion event. Okay, so the network starts from 1 and ends in 7. Okay, we cannot have like this also, one more event like this. We cannot have it like this. Okay, what we should do, we have to again connect these to another event, that is 9. Okay, so always we should have only one starting event and only one ending event. Is it clear? Okay, if in the question they will give us a table. Okay, if you draw the table and you are getting two events like this, 7 and 8 separately, then what you should do? 7 and 8 should be connected together to another node, okay, and give it a higher number. Is it clear? Okay, when we do the problems, it will be more, so don't worry. Next one, the general rule for numbering the event is the head event should have always a number that is greater than the tail. Okay, we have already told that now. Here, this is the tail and this is the head. Okay, tail should be always represented by a smaller number and head should be represented by a bigger number. Okay, next one. Yeah. An activity must be uniquely be identified by starting and completion event, which implies that an event should not get repeated or duplicated. Okay, event should not get repeated or duplicated. And B is activities should either be represented by symbols or by corresponding ordered pair of starting completion events. That we already told. No, activities can either be represented by A or it can be represented by the starting and the ending node. Okay, that way also we can represent. The logical sequence between activities must follow the rules. Some of the rules are there for the logical sequence. Okay, an event cannot occur until all the incoming activities are completed. Okay, here we have an event. Okay, to this event we have these activities A, B, C. Okay, this event that is numbered by 2. Okay, 2 cannot be started. Okay, 2 cannot be started until activities A, B and C are completed. Clear? So there is a sequence for the logical sequence for this diagram. Next one, an activity cannot start unless all preceding activities on which it depends have been completed. Okay, for example, here we have an activity called as B. Okay, B cannot start unless A is completed. Okay, similarly, if you have an activity here D, okay, D cannot be started unless A, B and C are completed. Okay, so what we write in this arrow mark is called as the activity and what we write inside the circle is called as an event. Okay, so here it is events. Then we have here, though dummy activity, you see, though dummy activity does not have any resource or time, it still has to follow the logical sequence. Okay, when we draw the dummy activity, That is the dummy activity. Yeah. Here we have the dummy activity. D1 is represented as the dummy activity. Okay. This dummy activity will not have any time or anything like that. Okay. In critical CPM method, no, critical path method, or in part also. In part also, what we'll do is, these are the activities, no? In the bracket, we'll be writing the duration of this activity. For example, A takes 2 weeks. B takes 3 weeks. Like that, we'll be writing. Okay, the duration of completion of activity will be written inside this bracket. Okay. For dummy activity, what will happen? Dummy activity will not have any duration. Okay. So this is just to represent the precedence. Okay. Before C, A and B needs to be completed. Okay. So just to represent that relationship, we are using this dummy activity. Other than that, this dummy activity does not have any other meaning. Okay. There is no resources that is allocated. There is no duration for this dummy activity. Okay. But what happens is, dummy activity, the C can be completed only after B and A completes. Okay. For example, or otherwise, over here, if we have another activity called as Z. Okay. D1 can be completed only after B is completed as well as Z is completed. Okay. So before B we have Z, no. So this dummy activity can be started only after B and Z is completed. Okay. So the logical sequence is very well applicable to the dummy activity, but the only thing is, this dummy activity will not have any duration, okay, or any resources that are allocated to it. Clear? Next, we have some of the errors, common errors that are made in drawing the network diagram. Okay, first one is called as a looping or cycling. Okay, looping or cycling means, over here, can you see? We start with A activity, then it goes to C, then it goes to, here you have, then it goes to D, then it goes to B. Okay, again what happens? Again what happens? Again it goes to C, again D, again B. Okay. That's the arrow. Okay. So what happens? There is a loop that is formed over here. No, this is actually an error. Okay. It is called as a looping error. Okay. So once we start with A, we should have a proper sequence that is followed. We should not go into an infinite loop. Okay. That is called as a looping error. Then next error that we can make is dangling error. Dangling means, see over here, you start with A, then you go for B. Okay. But in between A and B, we have another activity called as C. Okay. C is the ending of C is represented by 3. Okay, the event 3. But what happens? This C activity and the activity over here B, they should actually have one common ending point. No, we already told. Okay, we already told here. See, if there is two activities that is forming two separate branches, at the end what we should do, we have to connect these to a single completion node, that is 9. Okay, if it is not done so, if a single completion node is not made in this network, then it is called as a dangling node. Okay, it just hangs out there. Okay, so this has to be actually connected to the fourth one, and then we should have one single completion node. If we don't have a single completion node for the entire diagram, then it is called as a dangling error. Okay, then we have the dummy. Dummy we have already seen. Okay. Okay, dummy, I'll just tell you one more thing that we should, you have to take care of dummy. Okay, I think I'll do that better when we have some problems. Okay. Okay, then one more reason why we have dummy is because, can you see this network over here? What happens is A and B has to be completed for C and D to start. Okay. If there is no proper meaning like that, okay, if there is no such logical meaning, for example, C and D can start even after A and B is not completed. If there is some meaning like that, in that cases also you can go for a dummy variable. Okay, for example, A is connected to C and we have A that is flowing through the dummy variable, and then B is there, and then D is there. So D can be started. Okay, there is no need of some dependency created. If there is no dependency that is needed, in such cases also we can have a dummy that is drawn. Okay. This kind of cases does not come for the our exam point of view. So just you can note it. Okay. If there is no much dependency, okay, that is there in this diagram. Okay, dependency means C and D need to start only after A and B is completed. If there is no dependency, okay, like that. Okay, in such cases also we can go for a dummy variable. Okay, but this is not applicable for us in our exams, exam point of view. Okay, only the first case, no? When two parallel activities come, in such cases you have to go for dummy. Okay, for theory part you can just know that if there is no logical, okay, meaning to this network, in such cases also we can go for a dummy. Okay, so I'll just stop the recording. Okay, so now we'll see how to draw this network diagram. Okay, for solving this project management using CPM or using PERT, first of all, you need to draw the network diagram. Okay, so first we'll see two problems on how to draw a network diagram, and then we'll go into CPM and PERT. Okay, so this is a question. Using this question, we have to draw the network diagram. Okay, just read the question. Listed in the table are the activities and sequencing necessary for a maintenance job on the heat exchanger in a refinery. Okay, so what is given? Activities are given A to, how many activities are there here? A to J. Okay, A to J activities are given. Then description is given. First activity means dismantle pipe connections. Similarly, all the descriptions are given. From your exam point of view, the description part is not necessary. Okay. Next one is predecessor activity. Okay, what is the meaning of that? Predecessor activity means before a predecessor activity has to be completed. Okay. So how will you draw this? In the network chart, from this activity to this activity, that will be the meaning. Okay, or in other words, from means this is going to be the tail. Okay, this will be the tail and this will be the head. That is the meaning. Okay, that is the meaning of this. Okay, so first of all, A needs to be completed. After A, which activity? B needs to be completed. Okay, then again B needs to be completed. After that, C needs to be completed. Okay, then again, B needs to be completed and then D needs to be completed. So that is the meaning of that. Okay, so this is the tail activities that is given here and these are the head activities. Or from this activity, you have to draw this activity. That is the meaning. Okay, so see, the best method to draw the network analysis is first of all, you have to take a pencil. Okay, that is the first thing that you have to do. Okay, we are going to draw it by trial and error method. Okay, so once you draw something, but after that you see some other details that are there. Okay, down the table. Okay, so then we'll have to rub few diagrams on networks and then we'll have to redraw. Okay, so for exam, be careful. You have to draw the network diagram only using the pencil. Okay, and keep a rubber also with you so that you can rub it out if you make any mistakes. Okay, so I'll show you how to draw the network diagram. Okay, so over here, we have a dash. A dash means A is the first starting activity. Okay, if they are telling B also, like A here, suppose they are telling A, B, and predecessor activity, if they put dash, then what is the meaning? A and B are the starting activities. Okay, A and B are the starting activities. But in rules, what did you learn? Only one starting event should be connected to these activities. No, so how will you draw? You have one starting activity. Okay, so starting event, and from that you will draw A and B. Okay, so that is how you will draw if there is two dash. Okay, A and usually what we will do if there is two dash, how will we draw? Here we will have A and here we will have B. Like this we'll draw. But according to network analysis, what is the rules? Only one starting node should be there. So what will we draw? What will we do? We will delete these two zeros. We will join these two to a single node. Okay. So single node and from that A and B will come. Okay. That is how you will draw this one. If there are two dash. If there are one more dash is there. How will you draw? A single node. From that single node you have A, B, and C. Okay, this is how you will draw. network diagrams. Okay, but in our case, we have only one single dash over here. That means A is only the starting node. Okay, the others are going to follow A. Okay, so we'll draw it. Just see how we'll draw. So first of all, there's a dash and there is an A node. So we'll have the starting node. And from that, always be careful. You have to draw using the pencil. You can see. Yeah. So this is the meaning. First one, we draw A. Okay, so dash is there. So there is no predecessor for A. There is no activity before A. That is the meaning. Okay, so A we have drawn. Next one. After A, B. Okay, so after A, I'm going to draw B. Okay, after A, we have B, activity B. Next one, after B, C. After B, we have C. Okay, next one. After B, we are having D. After B, we are having D means from B itself, there is one more node that is coming, that is called as D. Okay, did you see? D. Okay, next one over here. After B, E. After B, D we have already drawn here. They are telling after B there is one more node that is called as E. Okay. So from B itself we have C, D, E over here. Did you see? From B itself we have C, D and E. Okay. Next one. After C we have F. Okay. After C we have F. Okay. Next one. After C we have G. Okay, so after C we are having one more node that is G. Okay, so I will draw G here. You have to put the arrows. Okay, don't miss out the arrows. So after C we are having G. Now what they're telling, F and G together we are having H. Okay, F and G together we are going to have H. Okay, so how will you draw? F and G together we have one node called as H. This is how you will draw, right? Okay, but you should not draw like this. Why? We have to name these. Okay, we don't have any names over here. So what we'll draw? We'll just remove the circle and then we can draw G like this also. No, so G here, and we can remove this and the circle and draw straight one to here, and then we can name it as F. Okay, but do you see anything confusing here? What did I say? See, initially what did we draw? G we have like this, F we have like this, okay? And then from C we have G and we have F. And what is there? F and G together forms H. So F and G I put a node and then together forming H. Okay, but we don't have any names for these two arrows. So what is the meaning is, you need to remove the circle and then draw one single line. You have to remove the circle and then draw one single line. You can name that single line as F and this single line as G. Okay, but what happens here? I'll just rub it out and draw and show. What is the meaning? Here we have G and here we have F. Okay, but is this according to network analysis? Okay, this is not according to network analysis. Why? Because we should not have any parallel nodes. Okay, for this activity, which is a tail event, starting activity is this one. Okay, for F also it is this one. Similarly, for this G, what is the ending activity? This one. What is for F? What is the ending activity? It is this one. So this is actually like this our parallel nodes. Parallel nodes are not allowed in network analysis. Okay, so what we will do? We have to go for dummy variables. Okay, so what I'll do is I have to check, okay, whether G and F is used by anybody else in this network. Okay, just go traverse below. Okay, you have to check whether G and F is used individually by anybody else in this network. Individually means this two together has to form H. Okay, other than that, just check if G alone is a predecessor for some other activity. Okay, is it clear? G alone is a predecessor. You have to check whether G alone is a predecessor or F alone is a predecessor for some other activity. Okay, just go down. Till here we have completed now D, E, H, I. Okay, in this place we don't have F and G mentioned. Okay, F and G is not mentioned anywhere below this predecessor column. Okay, that means F and G, they are not predecessors for any other activity. Only H is going to follow from F and G. Did you understand? ഇങ്ങനെ ഒരു സിറ്റുവേഷൻ വരുവാണെങ്കിൽ ദിസ് ഇസ് നോട്ട് അലൗഡ് ബിക്കോസ് ദിസ് ഇസ് പാരലൽ. ഓക്കെ, സോ ദിസ് ഇസ് നോട്ട് അലൗഡ് ഇൻ നെറ്റ്വർക്ക് അനാലിസിസ്. അപ്പൊ നമ്മൾ എന്ത് ചെയ്യണം? നമ്മൾ ഇവിടെ ഒരു ഡമ്മി വേരിയബിൾ ഇൻട്രൊഡ്യൂസ് ചെയ്യണം. ഓക്കെ, ഡമ്മി ആർക്ക് കൊടുക്കണം? എഫിന് കൊടുക്കണോ ജിക്ക് കൊടുക്കണോ? ദാറ്റ് ഇസ് ഡിസൈഡഡ് ബൈ ചെക്കിംഗ് യുവർ പ്രെഡിസസർ ടേബിൾ. ഓക്കെ, ജി തന്നെ ആയിട്ട് ആരെങ്കിലും വേറെ ആരെങ്കിലും ജീനെ പ്രെഡിസസർ ആയിട്ട് യൂസ് ചെയ്യുന്നുണ്ടോ എന്ന് നോക്കണം. ഓക്കെ, അതുപോലെ തന്നെ എഫിനെ ആരെങ്കിലും തന്നെ പ്രെഡിസസർ ആയിട്ട്. ഓക്കെ, ഫോർ എക്സാമ്പിൾ ഇപ്പൊ നമ്മൾ ജി വരച്ചു, ജിയിൽ നിന്ന് വേറൊരു വേരിയബിൾ, ജി ഇവിടെ ഉണ്ട്, ജിയിൽ നിന്ന് വേറൊരു വേരിയബിൾ ഐ വരുന്നുണ്ടോ എന്ന് നോക്കണം. അതുപോലെ ഇപ്പൊ എഫ് നമ്മളിവിടെ വരച്ചു, എഫിൽ നിന്ന് വേറെ ഒരു ജെ വരുന്നുണ്ടോ എന്ന് നോക്കണം. ഓക്കെ, അല്ലെങ്കിൽ ഏതെങ്കിലും ഒരു ആക്ടിവിറ്റി. അങ്ങനെ ജിക്ക് തന്നെ ഇനി വേറെ ഏതെങ്കിലും ജി മാത്രമായിട്ട് പ്രെഡിസസർ ഉള്ള ഏതെങ്കിലും ആക്ടിവിറ്റി ഉണ്ടോ, അല്ലെങ്കിൽ എഫ് മാത്രം പ്രെഡിസസർ ആയിട്ടുള്ള വേറെ ഏതെങ്കിലും ആക്ടിവിറ്റി ഉണ്ടോ എന്ന് നമ്മൾ നെറ്റ്വർക്ക് ഡയഗ്രാമിൽ നോക്കണം. ഓക്കെ, അങ്ങനെ ഇല്ലെങ്കിൽ നമ്മൾ ഇതിൽ ആർക്ക് വേണമെങ്കിലും ഡമ്മി കൊടുക്കാം. ഓക്കെ, പക്ഷെ അങ്ങനെ ഉണ്ടെങ്കിൽ നമ്മൾ എന്ത് ചെയ്യണം? ഇപ്പൊ ജീനെ പ്രെഡിസസർ ആക്കുന്നത് ഐ മാത്രമായിട്ട് ഒരു വേരിയബിൾ ഉണ്ട് എങ്കിൽ ജിക്ക് വേണം നമ്മൾ അവിടെ ഡമ്മി കൊടുക്കാൻ. ഓക്കെ, ഈ കേസിൽ നമുക്ക് ജിയും എഫും ഇതിൽ ആർക്കാണോ ഡമ്മി കൊടുക്കേണ്ടത് നമുക്കറിയില്ല. അപ്പൊ നമ്മൾ നേരെ താഴെ ഇവിടെ വരെ നമ്മൾ എത്തി, ഇവിടുന്ന് താഴോട്ട് നോക്കി, ഇവിടുന്ന് താഴോട്ട് ആർക്കും എഫും ജിയും വരുന്നില്ല അല്ലെ? ഇവിടെ ഡിയും ഇയും എച്ചും ഐയും ഒക്കെയാണ് വരുന്നത്, ഇവിടെ എഫും ജിയും വരുന്നില്ല. സോ വി ക്യാൻ ഇൻട്രൊഡ്യൂസ് ഡമ്മി either for എഫ് or either for ജി. ഓക്കെ, there is no issues. ഓക്കെ, so what I'm going to do is ഞാൻ ജിക്ക് ഇവിടെ ഞാൻ ഡമ്മി ഇൻട്രൊഡ്യൂസ് ചെയ്യാൻ പോവാണ്. How will I introduce dummy here? ഡമ്മി എങ്ങനെ ഞാൻ ഇൻട്രൊഡ്യൂസ് ചെയ്യുന്നത്? ഇവിടുന്ന് ഞാൻ ഇവിടെ ഇങ്ങോട്ട് ഒരു വരച്ചിട്ട് ഇവിടെ ജി മാർക്ക് ചെയ്തു, ജിയിൽ നിന്ന് ഞാൻ ഇങ്ങോട്ടേക്ക് D1 എന്ന് പറയുന്ന ഡമ്മി ഇട്ടു. ഓക്കെ, സോ വാട്ട് ഇസ് ഇൻ എഫക്ട് വാട്ട് ഹാപ്പൻസ്? എഫ് ഇത് കൂടെ വന്നു, ജി നേരെ ഇത് കൂടെയും വന്നു, ആൻഡ് എഫ് ആൻഡ് ജി ടുഗദർ ഗോസ് ടു എച്ച്. ഓക്കെ, നമ്മുടെ നെറ്റ്വർക്ക് അനാലിസിസ് പ്രകാരം ദിസ് ഇസ് ഓക്കെ ബിക്കോസ് ജി നേരെ ഇങ്ങോട്ടും എഫ് നേരെ ഇങ്ങോട്ടും വരുവാണെങ്കിൽ അത് പാരലൽ നോട്ട്സ് ആയി പോകുമായിരുന്നു. പാരലൽ നോട്ട്സിനെ നമ്മൾ എലിമിനേറ്റ് ചെയ്യണം. ഫോർ ദാറ്റ് ഐ ഹവ് ഇൻട്രൊഡ്യൂസ്ഡ് എ ഡമ്മി ഇൻ ജി. ഓക്കെ, ജി അപ്പൊ ജി നമ്മൾ ഒരു നോഡിലേക്ക് വരച്ചിട്ട് അവിടുന്ന് ഒരു ഡമ്മി വേരിയബിൾ എടുത്ത് ഈ നോഡിലേക്ക് കൊടുത്തു. ഓക്കെ, ഈ നോഡിലേക്ക് കോമൺ ആയിട്ട് എഫ് എന്ന് പറയുന്ന നോഡ് വരുന്നുണ്ട്, അതിൽ നിന്ന് എച്ച്. ഓക്കെ, അപ്പൊ നമ്മുടെ ഇവിടെ എന്താ പറഞ്ഞേക്കണേ? എഫും ജിയും ഒരുമിച്ച് എച്ച് ഫോം ചെയ്യണം. ഓക്കെ, സോ എഫും ജിയും ഒരുമിച്ച് എച്ച് ഫോം ചെയ്തു. ഇൻ ബിറ്റ്വീൻ there is a dummy. Okay, so there is no problem with this network. Okay, next one, D, E, H together has to form I. Okay, where is D? D, E and H together has to form another D, E, H together has to form I. Okay, so what will happen? ഞാൻ എന്ത് ചെയ്യണം? ഇവിടുന്ന് ഇങ്ങോട്ട് കണക്ട് ചെയ്യും, ഇവിടുന്ന് ഇവിടെ ഒരു ഇയുടെ നോഡ് ഉണ്ടല്ലോ അതിനെ ഇങ്ങോട്ട് കണക്ട് ചെയ്തു. സോ ഡി, ഇവിടെ ഡി ഉണ്ട്, ഇവിടെ ഇ ഉണ്ട്, ഇവിടെ എച്ച് ഉണ്ട്, ടുഗദർ ഇസ് ഗോയിങ് ടു ഫോം ഐ. ഓക്കെ, ബട്ട് ഇസ് ദിസ് പോസിബിൾ? ഇവിടെ നമുക്ക് ഈ രണ്ട് ആരോസിനെ നെയിം ചെയ്യാൻ വേണ്ടിയിട്ട് നമുക്ക് വേറെ നെയിംസ് ഒന്നും ഇല്ല. സോ വാട്ട് ഇസ് ദ മീനിങ്? ഈ നോഡിനെ റിമൂവ് ചെയ്ത് എനിക്ക് ഡയറക്റ്റ് ആയിട്ട് ഇങ്ങോട്ട് കണക്ട് ചെയ്യാൻ പറ്റും. അതുപോലെ ഈ നോഡിനെ റിമൂവ് ചെയ്ത് എനിക്ക് ഡയറക്റ്റ് ഇങ്ങോട്ട് കണക്ട് ചെയ്യാൻ പറ്റും. I'll just do that. Okay, D and E. Okay, okay, so here I am having D and here I am having E. Okay, D and E together. So H, D and E together. H ഉം E ഉം D ഉം കൂടെ join ചെയ്തിട്ട് വേണം I form ചെയ്യാൻ. So H I have through this one. Okay, D I have through this arrow and E I have through this one, and that is going to form I. Okay, is this possible? Is this possible? According to network analysis, is this possible? This is also not possible. Unfortunately, this is also not possible. Why? Because here D and E forms parallel network. It is according to this one, right? Over here, D and E is forming parallel network. So that is also not possible. We have to introduce dummy either to E or to D. Okay, how will you decide which one? You will have to check the table. Okay, D യും E യും ഇൻഡിവിജ്വൽ ആയിട്ട് ഇനി വേറെ ആരെങ്കിലും യൂസ് ചെയ്യുന്നുണ്ടോ പ്രെഡിസസർ ആയിട്ട് എന്ന് നമ്മൾ നോക്കണം. ഓക്കെ, ഡി ആൻഡ് ഇ. ഡി ആൻഡ് ഇ വേറെ ഇവിടെ വരെ നമ്മൾ എത്തി. ഇവിടുന്ന് കഴിഞ്ഞിട്ട് ഡി ആൻഡ് ഇ ആരെങ്കിലും യൂസ് ചെയ്യുന്നുണ്ടോ? ഇല്ല, ഐ മാത്രമേ ഇവിടെ വരുന്നുള്ളൂ. ഓക്കെ, സോ വി ക്യാൻ ഇൻട്രൊഡ്യൂസ് ഡമ്മി either to D or E. ഓക്കെ, അതിനെ എങ്ങനെ ഇൻട്രൊഡ്യൂസ് ചെയ്യണേ? Here, if I am okay, D നേരെ ഇങ്ങോട്ടേക്ക് ഞാൻ പോയി, ഓക്കെ, ഡി ഇങ്ങോട്ടേക്ക് പോയി. ഞാൻ ഇക്ക് ഞാൻ ഡമ്മി ഇൻട്രൊഡ്യൂസ് ചെയ്യുവാണ്. ഇക്ക് ഡമ്മി എന്ന് പറഞ്ഞാൽ ഇതിന്റെ ഇടയ്ക്ക് വെച്ച് ഞാൻ ഇവിടെ ഒരു നോഡ് ഇൻട്രൊഡ്യൂസ് ചെയ്തിട്ട് ഇവിടെ ഞാൻ ഡോട്ടഡ് ലൈൻസ് ഇട്ട് കഴിഞ്ഞാൽ ഇറ്റ് വിൽ ബിക്കം എ ഡമ്മി. ഓക്കെ, സോ ഇവിടെ ഓൾറെഡി D1 യൂസ് ചെയ്തിട്ടുണ്ട്. സോ ഹിയർ ഐ വിൽ നെയിം ഇറ്റ് ആസ് D2. ഓക്കെ, സോ ഇവിടെ ഒരു നോഡും ഉണ്ട്. ഓക്കെ, സോ ഹിയർ വി ഹാവ് ഇ, പിന്നെ എച്ചും ഡിയും ഇയും. ഓക്കെ, എച്ചും ഡിയും ഇയും നമുക്ക് ഐ ഫോം ചെയ്തു. ഓക്കെ, ദർ ഇസ് നോ ഡൗട്ട് നോ. സോ ദാറ്റ് ടുഗദർ ഹാസ് ഫോംഡ് ഐ. ആൻഡ് ഇത് രണ്ടും പാരലൽ നോട്ട്സ് ആയതുകൊണ്ട് ഇതിനിടയ്ക്ക് ഞാൻ ഒരു ഡമ്മി ഇൻട്രൊഡ്യൂസ് ചെയ്തു. അങ്ങനെ അതിനെ D2 എന്ന് വിളിച്ചു. സോ ദീസ് ത്രീ ആർ ഗോയിങ് ടു ഫോം ഐ നൗ. ഓക്കെ, നെക്സ്റ്റ് വൺ I is the, after I we have to draw J. Okay, so after I am drawing J. Okay, so here I have J. Okay, this is how you will draw the network diagram. ഇത്ര വരച്ച് കഴിഞ്ഞിട്ട് what you can draw is കുറച്ചുകൂടെ നീറ്റ് ആയിട്ട്, ഇതിപ്പോ നമ്മൾ കുറെ റബ്ബിംഗ് ഒക്കെ ചെയ്തല്ലോ, അപ്പൊ ഇത് ഇത്തിരി കൂടെ നീറ്റ് ആയിട്ട് we can draw into another diagram. Okay, ഇപ്പൊ എക്സാമ്പിൾ ഇങ്ങനെയാണ് നെറ്റ്വർക്ക് ഡയഗ്രാംസ് വരയ്ക്കുന്നത്. Okay, so make sure you draw the network diagram only with the pencil. ഓക്കെ, പിന്നെ എവിടെയെങ്കിലും പാരലൽ നോട്ട്സ് വരുന്നുണ്ടോ നോക്കുക. പാരലൽ നോട്ട്സ് വരുന്നുണ്ടെങ്കിൽ we have to decide for which activity we have to give the dummy. Okay, പാരലൽ ആക്ടിവിറ്റീസ് വരുന്നുണ്ടെങ്കിൽ that is not allowed in network analysis, we have to introduce dummy. ഓക്കെ, ഡമ്മി നമുക്ക് ആർക്ക് ഇൻട്രൊഡ്യൂസ് ചെയ്യണം എന്ന് നോക്കണം. ഓക്കെ, ഇൻഡിവിജ്വൽ ആയിട്ട് ഇപ്പൊ ജിയും എഫിനും ഇവിടെ പാരലൽ നോട്ട്സ് ആണ്. ജിയും എഫും ആർക്ക് വേണം നമ്മൾ ഡമ്മി നോട്ട് ഇടാൻ വേണ്ടിയിട്ട്? ഇപ്പൊ ജിനെ ഒറ്റയ്ക്ക് വേറെ ആരെങ്കിലും യൂസ് ചെയ്യുന്നുണ്ടെങ്കിൽ ജിക്ക് വേണം നമ്മൾ ഡമ്മി ഇടാൻ വേണ്ടി. ഓക്കെ, അല്ലെങ്കിൽ എഫിനെ വേറെ ഒറ്റയ്ക്ക് വേറെ ആരെങ്കിലും യൂസ് ചെയ്യുന്നുണ്ടെങ്കിൽ എഫിന് വേണം നമ്മൾ ഡമ്മി കൊടുക്കാൻ വേണ്ടി. ഓക്കെ, ഈ കേസിൽ ജിയും എഫും വേറെ ആരും യൂസ് ചെയ്യുന്നില്ല. അപ്പൊ ജിക്ക് ഡമ്മി അല്ലെങ്കിൽ എഫിന് ഡമ്മി നമുക്ക് ഇൻട്രൊഡ്യൂസ് ചെയ്യാം. ആ നേരെയുള്ള ലൈനിനകത്ത് ഇടയ്ക്ക് ഒരു നോഡ് കൂടെ വരച്ച് ബാക്കിയുള്ള ലൈൻ ഡോട്ടഡ് ആയിട്ട് ഇട്ടാൽ വി വിൽ ദാറ്റ് വിൽ ബിക്കം എ ഡമ്മി നോഡ്. ഓക്കെ, ഡമ്മി ആക്ടിവിറ്റി. ഓക്കെ, അപ്പൊ അങ്ങനെ മാത്രമേ നെറ്റ്വർക്ക് അനാലിസിസിൽ വരയ്ക്കാൻ പാടുള്ളൂ. ഓക്കെ, സോ വിൽ ഡു വൺ തിങ്, വിൽ സീ വൺ മോർ നെറ്റ്വർക്ക് അനാലിസിസിന് വേണ്ടിയിട്ട് ഒരു ഡയഗ്രാം കൂടെ കാണാം. അത് കഴിഞ്ഞിട്ട് we will go for CPM. Okay, so here we have one. Okay, so we'll draw for this one. Okay, you have to tell me which one has to follow which one. Okay, ഇവിടെ ആക്ടിവിറ്റി നമ്മൾ എഴുതിയിട്ടുണ്ട്, predecessor activity എഴുതിയിട്ടുണ്ട്. predecessor activity എന്ന് പറഞ്ഞാൽ ഈ ആക്ടിവിറ്റി കഴിഞ്ഞിട്ട് വേണം ഈ ആക്ടിവിറ്റി ചെയ്യാൻ. Okay, so this one will follow this one. Okay, അതാണ് അതിന്റെ മീനിങ്. ഫ്രം ദിസ് നോട്ട്സ് വി ഹാവ് ടു ഡ്രോ ദ ഫസ്റ്റ് കോളം. അതാണ് അതിന്റെ മീനിങ്. ഓക്കെ, സോ ഫസ്റ്റ് വൺ ഇറ്റ്സെൽഫ് വി ആർ ഹാവിംഗ് വൺ ഡാഷ് ദേർ. ഓക്കെ, അപ്പൊ ഞാൻ എന്ത് ചെയ്യണം? എ ആണ് എന്റെ സ്റ്റാർട്ടിംഗ് നോഡ് എന്ന് എനിക്ക് അതിൽ നിന്ന് മനസ്സിലായി. ഓക്കെ, എ ഇസ് മൈ സ്റ്റാർട്ടിംഗ് നോഡ്. സോ ഐ വിൽ ഡ്രോ വൺ സർക്കിൾ. എ ഇസ് മൈ സ്റ്റാർട്ടിംഗ് നോഡ്. ഐ വിൽ റൈറ്റ് എ ദേർ. ഓക്കെ, പിന്നെ എയിൽ നിന്ന് ബി. ഫ്രം എ വി ഹാവ് ബി. ഫ്രം എ വി ഹാവ് സി. എയിൽ നിന്ന് തന്നെ സിയും വരുന്നുണ്ട്. ഓക്കെ, എയിൽ നിന്നാണ് സി കേട്ടോ. അപ്പൊ ഇവിടെ ഞാൻ ഇപ്പൊ വരച്ച തെറ്റിയതാണ്. ഇവിടുന്ന് വരയ്ക്കരുത്. ഇവിടെയാണ് എ വന്ന് എൻഡ് ചെയ്യുന്നത്. എയിൽ നിന്ന് വേണം അടുത്ത സി വരയ്ക്കാൻ. ഓക്കെ, സോ ഇറ്റ് വിൽ ബി ലൈക്ക് ദിസ്. ഓക്കെ, ദിസ് ഇസ് റോങ്. ദിസ് ലൈൻ ഷുഡ് നോട്ട് ബി. സ്റ്റാർട്ടിങ് നമുക്ക് ഒരു ആക്ടിവിറ്റി മാത്രമേ സ്റ്റാർട്ടിംഗ് നോഡിൽ നിന്ന്, അല്ലെങ്കിൽ ഇപ്പൊ ഇവിടെ പറഞ്ഞിരിക്കുന്ന എയിൽ നിന്ന് സി വരയ്ക്കണം എന്നാണ് പറയുന്നത്. സോ എ എൻഡ് ചെയ്യുന്നത് എവിടെയാണോ അവിടുന്ന് വേണം സി സ്റ്റാർട്ട് ചെയ്യാൻ വേണ്ടിയിട്ട്. So എയിൽ നിന്ന് സി കഴിഞ്ഞു. ഡി. സിയിൽ നിന്ന് ഡി. സിയിൽ നിന്ന് വി ഹാവ് ഡി. ഓക്കെ, ബിയിൽ നിന്ന് ഇ. ബിയിൽ നിന്ന് ഇ. ഓക്കെ, നൗ സിയിൽ നിന്ന് എഫ്. ഫ്രം സി എഫ്. ഓക്കെ, ഡി ആൻഡ് ഇ ടുഗെദർ ജി. ഡിയും ഇയും ടുഗെദർ ജി. ഓക്കെ, സോ ഹൗ വിൽ ഐ ഡ്രോ ഇറ്റ്? എനിക്കത് ഇങ്ങനെ രണ്ടും കൂടെ വരച്ചിട്ട് ഇവിടെ വരച്ചിട്ട് ഇങ്ങനെ കൊണ്ടുവന്ന് ജി വരയ്ക്കാം. ഓക്കെ, അങ്ങനെ വരയ്ക്കാം. ഡിയും ഇയും ടുഗെദർ ജി ഫോം ചെയ്യണം എന്നല്ലേ പറഞ്ഞത്. ബട്ട് വാട്ട് ഹാപ്പൻസ്, എനിക്ക് ഈ രണ്ട് ലൈൻസിന് പേര് കൊടുക്കാൻ ഒന്നുമില്ല. സോ വാട്ട് ഐ ഹാവ് ടു ഡു? ഈ നോഡിനെ റിമൂവ് ചെയ്ത് ഇതൊരു ഇങ്ങോട്ടേക്ക് വരയ്ക്കണം. അതുപോലെ ഈ നോഡിനെ റിമൂവ് ചെയ്ത് ഡി ഒന്ന് നീട്ടി വരയ്ക്കണം. ഓക്കെ, ബിക്കോസ് ഐ ഡോണ്ട് ഹാവ് എനി നെയിംസ് ഫോർ ദീസ് ടു ലൈൻസ്. റിമൂവ് ദിസ് നോഡ് ഇൻ ബിറ്റ്വീൻ ആൻഡ് ദെൻ ഡ്രോ എ ബിഗർ ലൈൻ. അത് ഡിയും ഇവിടുത്തെ ലൈന് ഇയും ആവും. ഓക്കെ, സോ നിങ്ങൾ ആദ്യം വരയ്ക്കുമ്പോൾ ഇത്രയും ലൈറ്റ് ആയിട്ട് വരയ്ക്കാം, അല്ലെങ്കിൽ വായിക്കാൻ ഇത്ര ബുദ്ധിമുട്ടുണ്ട്. Okay, here I have one node. I have E. Okay, and here I have another node. This is D. Okay, these are not parallel nodes. Parallel nodes alla. കാരണം E യുടെ സ്റ്റാർട്ടിംഗ് നോഡ് ഇതാണ്, D യുടെ സ്റ്റാർട്ടിംഗ് നോഡ് ഇതാണ്. ഇത് രണ്ടും കൂടെ എൻഡ് ചെയ്യുന്നത് മാത്രം ഒരു നോഡ്, അത് കുഴപ്പമില്ല. രണ്ടിനും ഒരേ സ്റ്റാർട്ടിംഗ് നോഡ് എൻഡിംഗ് നോഡ് ആണെങ്കിൽ മാത്രമേ അത് പാരലൽ നോഡ്സ് ആയിട്ട് മാറുള്ളൂ. ഓക്കെ, സോ ഹിയർ വി ഹാവ് ഡ്രോൺ ഡി ആൻഡ് ഇ ടുഗദർ ജി. ഓക്കെ, നെക്സ്റ്റ് വൺ, ജിയിൽ നിന്ന് എച്ച്, ഫ്രം ജി എച്ച്. ഓക്കെ, നെക്സ്റ്റ് വൺ, എച്ചിൽ നിന്ന് ഐ, ഫ്രം എച്ച് I. From F, J. Where's F? From F, we have J. Okay. Next one. From I and J together, we have K. I and J, we are having K. നമ്മൾ എന്ത് ചെയ്യും? ഇങ്ങനെ വരച്ചു, ഇങ്ങനെ വരച്ചു. ഇവിടെ നടുക്കൊരു നോഡ് ഉണ്ടെന്നോ അതിൽ നിന്ന് നമ്മൾ K വരയ്ക്കും. ഓക്കെ, അങ്ങനെയല്ലേ സാധാരണ. പക്ഷെ എന്ത് ചെയ്യാം? ഇവിടെ ഈ ലൈനും നമുക്ക് വേറെ നെയിം ഒന്നും കൊടുക്കാനില്ല. സോ വാട്ട് വിൽ ഡു? We will remove these nodes. ഈ നോഡ്സ് മാറ്റിയിട്ട് നേരെ ഒരു സെൻട്രൽ നോഡ് വരച്ച് കോമൺ നോഡ് അതിലേക്ക് നമ്മൾ J കൊടുക്കും. Is it clear? നമുക്ക് ഇവിടെ ഇങ്ങനെ ജെയിൽ നിന്നും ഐയിൽ നിന്നുമാണ് കെ വരുന്നത്. അപ്പൊ നമ്മൾ ഇത് ഇങ്ങോട്ടും വരച്ചിട്ട് കോമൺ നോഡ് വരച്ച് കെ വരയ്ക്കാം. ഓക്കെ, ബൈ പ്രാക്ടീസ് നിങ്ങൾക്ക് മനസ്സിലാവും. അത് അങ്ങനെ ചെയ്യണതിന് പകരം ഈ നോഡ് ഇവിടെ റിമൂവ് ചെയ്യണം. ഈ നോഡ് ഇവിടെ റിമൂവ് ചെയ്തിട്ട് നേരെ നീട്ടി ഈ ഐയും ജെയും ഒരു കോമൺ നോഡിലോട്ട് വരച്ചിട്ട് അവിടെ നിന്ന് വേണം കെ കൊടുക്കാൻ. ഓക്കെ, സോ ഞാനിപ്പോ ഇത് വായിക്കുവാണ്. ഐയും ജെയും ഒരു കോമൺ നോഡിലോട്ട് കൊടുക്കാൻ പോകാം. ഓക്കെ, സോ ഹിയർ ഐ ഹാവ് ഇവിടെ ഐയും ഇവിടെ നിന്ന് ജെയും കോമൺ നോഡ് കെ. ഓക്കെ, സോ ഐ ആൻഡ് ജെ ടുഗദർ ഫോംസ് കെ. അത് കഴിഞ്ഞു. നെക്സ്റ്റ് കെയിൽ നിന്ന് എൽ, ഫ്രം കെ വി ഹാവ് എൽ. ഓക്കെ, ദെൻ എല്ലിൽ നിന്ന് എം, ഫ്രം എൽ വി ഹാവ് എം. Next one, now J in the N. Where is J? J in the, be very careful here. J in the N. Okay, be very careful here. From J, we have to draw N. Okay, from J, we have to draw N. But is this possible? ഈ നോഡ് എന്ന് പറഞ്ഞാൽ എന്താ? ജെയും ഐയും വന്ന് കോമൺ ആയിട്ട് എൻഡ് ചെയ്യുന്നതാണ് ഇവിടെ. അപ്പൊ ഇവിടെ എന്താ പറഞ്ഞേക്കണേ? ജെയിൽ നിന്ന് മാത്രം വേണം എൻ വരാൻ വേണ്ടിട്ട്. Okay, J in the alone. From only J, we have to get N. Okay, so what will we do? Dummy issue. Are you getting the feeling of introducing a dummy here? Okay, but according to previous tables, J and I join J and I join K. Okay, so J and I join K. Okay, but later J in the N. Okay, Jയിൽ നിന്ന് N വരയ്ക്കണമെങ്കിൽ what happens? Can I introduce a note like this? എനിക്ക് ഇൻട്രൊഡ്യൂസ് ചെയ്യാൻ പറ്റുമോ? ഇതിന്റെ അർത്ഥം എന്താ? ജെയും ഐയും കൂടെ ജോയിൻ ചെയ്യുന്നുണ്ട് ഈ കോമൺ നോഡില്. ഓക്കെ, അവിടെ നിന്നാണ് N വരച്ചാൽ അത് തെറ്റിപ്പോകും. ഓക്കെ, എനിക്ക് ജെ മാത്രം വേണം എന്നിലേക്ക് വരാൻ വേണ്ടി. സോ വാട്ട് വിൽ ഐ ഡു? ഞാൻ ഇവിടെ ഒരു ഡമ്മി ഇൻട്രൊഡ്യൂസ് ചെയ്യാൻ പോവാണ്. ഓക്കെ, ആൻഡ് ദാറ്റ് ഡമ്മി വേരിയബിൾ ഐ വിൽ ഗിവ് ടു ഈ ജെയും ഐയും കൂടെ ജോയിൻ ചെയ്യുന്ന പോയിന്റിലേക്ക് ഞാൻ ഡമ്മി കൊടുക്കും. ഓക്കെ, സ്ട്രെയിറ്റ് ആയിട്ടുള്ള നോഡ് ഞാൻ ആർക്ക് കൊടുക്കും? ജെ മാത്രമുള്ളത് ഞാൻ ആർക്ക് കൊടുക്കും? I will give it to N. Okay, so what I'm going to do is ഞാൻ ഇതിനിടയ്ക്ക് ഓക്കെ ജോയിൻ ചെയ്യുന്നത് രണ്ടും ജോയിൻ ചെയ്യുന്ന സ്ഥലത്ത് ഇപ്പൊ ജെയും ഐയും കൂടെ ജോയിൻ ചെയ്യുന്ന പോയിന്റ് ആണ് ഇവിടെ. ജോയിൻ ചെയ്യുന്ന പോയിന്റിലോട്ട് ഞാൻ ഡമ്മി കൊടുക്കും. ഓക്കെ, സോ ഐ എം ഇൻട്രൊഡ്യൂസിങ് വൺ നോഡ് ഹിയർ ആൻഡ് ഐ എം ഗിവിംഗ് എ ഡമ്മി. ഓക്കെ, ഇപ്പൊ ഇതിന്റെ അർത്ഥം എന്തായി? വാട്ട് ഇസ് ദ മീനിങ് ഓഫ് ദിസ്? I'm introducing dummy D1. Okay, so J comes over here, it goes through this dummy to this point. So in effect, I comes here and J comes through this and I have K. Okay, പക്ഷേ J യിൽ നിന്ന് എനിക്ക് I വരയ്ക്കണം. So what will I do? ഞാൻ ഈ നോഡ് J വന്ന് എൻഡ് ചെയ്യുന്ന പോയിന്റിൽ നിന്ന് I will draw which node? J യിൽ നിന്ന് N. Okay, so J യിൽ നിന്ന് N. Okay, so this is possible. പക്ഷെ നേരത്തെ നമ്മൾ ചെയ്തത് പോസിബിൾ ആയിരുന്നില്ല. കാരണം ജെയും ഐയും കൂടെ ഒരു പോയിന്റിൽ വന്ന് എൻഡ് ചെയ്താൽ നമ്മൾ ഇവിടുന്ന് എൻ വരയ്ക്കുവാണെങ്കിൽ വാട്ട് ഇസ് ദ മീനിങ്? എൻ സ്റ്റാർട്ട്സ് ഓൺലി ആഫ്റ്റർ ഐ ആൻഡ് ജെ കംപ്ലീറ്റ്സ്. അതായിരുന്നു അതിന്റെ മീനിങ്. പക്ഷെ അങ്ങനല്ല നമ്മുടെ ടേബിൾ പറഞ്ഞേക്കണേ. ജെ എൻഡ് ചെയ്യുന്നിടത്തു നിന്ന് എൻ സ്റ്റാർട്ട് ചെയ്യണം എന്ന് പറഞ്ഞാല് എന്നിന് ഒരേ ഒരു പ്രിഡിസസർ മാത്രമേ ഉണ്ടാവാൻ പാടുള്ളൂ. നമ്മൾ ഈ പോയിന്റിൽ നിന്നാണ് എൻ നേരത്തെ വരച്ചതെങ്കിൽ വാട്ട് ഹാപ്പൻസ്? എന്നിന് രണ്ട് പ്രിഡിസസർ ഉണ്ടാവുമായിരുന്നു അല്ലേ? അത് ചെയ്യാൻ പാടില്ല. അപ്പൊ നമ്മൾ എന്ത് ചെയ്യണം? ആ കോമൺ പോയിന്റിലേക്ക് ജെയുടെ ഡമ്മി കൊടുത്തിട്ട് ഈ ജെ ഒറ്റയ്ക്ക് നമ്മൾ എന്നിലോട്ട് വരയ്ക്കണം. Is it clear? Okay, next one, M and N together O. M and N together O. Okay, ഈ എന്നും ഈ എമ്മും കൂടെ ജോയിൻ ചെയ്ത് ഓ. ഓക്കെ, ദാറ്റ് അവിടെ ഒരു there is a small problem. നമുക്ക് ഈ ആരോനെയും നമുക്ക് നെയിം ചെയ്യാൻ ഒന്നുമില്ല. സോ വാട്ട് വിൽ ഡു, ഈ നോഡ് തട്ടിക്കളഞ്ഞിട്ട് നേരെ ഒരു ലൈൻ വരയ്ക്കും. ഈ നോഡും തട്ടിക്കളഞ്ഞിട്ട് ഇവിടെ നിന്ന് നേരെ എം വരയ്ക്കും. ഓക്കെ, സോ എം ആൻഡ് എൻ. ഓക്കെ, എം ആൻഡ് എൻ ഫോംസ് ഓ. ഒരു കോമൺ നോഡാണത്. എം ആൻഡ് എൻ ടുഗദർ എന്ന് പറഞ്ഞാൽ അതിനൊരു നമ്മൾ കോമൺ നോഡ് കൊടുത്തു. ഇവിടെ നിന്ന് എം വന്നു, പിന്നെ നമ്മുടെ ജെയിൽ നിന്ന് എൻ വന്നു, ആൻഡ് ദാറ്റ് ഫോംസ് എ കോമൺ തിങ് ദാറ്റ് ഇസ് ഓ. ഓക്കെ, സോ നൗ എം ഇവിടുന്നു എൻ ഇവിടുന്നു നേരെ ഒരു കോമൺ നോഡ്, അതിലേക്ക് ഓ വന്നു. സി, എം ആൻഡ് എൻ goes to O. Okay, is it clear? Okay, so this is how we will draw the network. ഇനി ഇത്ര വരച്ചു കഴിഞ്ഞാൽ what you do is ഇത്രയും neat ആയിട്ട് എടുത്ത് you can draw a pair figure, okay, in your answer paper. Okay.